At Genia, we're redefining how the built environment is engineered. Today, I'm excited to share a major milestone. Genia now supports 5/2 structural design, up to 5 stories of light from wood structure, over a 1 or 2 story of concrete podium. This typology is the most critical tool we have to address the urban housing crisis. According to recent data from the National Association of Home Builders, nearly 55% of new multifamily developments in dense urban areas now utilize podium designs. These structures are the backbone of affordable housing and senior living because they hit the sweet spot of economics, offering high-rise density without the prohibitive costs of a full-scale steel skyscraper. But while the market demand is undeniable, the engineering has remained a bottleneck. These projects force engineers to bridge 2 entirely different worlds: different materials, different code requirements, and a massive coordination headache at the transfer slab. Historically, this meant manual data entries, fragmented models, and weeks of back and forth. At Genia, we've built a way to eliminate these friction points. The process begins with the Revit architectural model. Instead of spending weeks rebuilding the model from scratch, our AI ingests the RVT file directly. As you can see, our engine immediately performs a deep architectural parsing, identifying key elements such as walls, columns, stairs, windows, and doors. Once the architecture is understood, we then move into the design requirement. On the left, Genia generates a precise loading map. Our system is code-aware from the first click, automatically recognizing and assigning different live load and dead loads for private rooms, corridors, and balconies. Simultaneously, Genia fetches site-specific environmental data through our ASCE 7 API integration. By pulling the location-based design requirements for wind, seismic, and snow, we ensure the structure design is code-compliant and fully optimized. Next, we leverage our AI to design the structure. For this type of building, we follow the 2-part approach in ASCE 7, starting with the wood design phase. On the left, Genia AI suggests a complete 2D layout, while on the right, you see a real-time 3D rendering of the timber superstructure. Every AI-suggested structural layout is instantly run through our proprietary analysis engine. Then, we design the concrete podium. Genia intelligently accounts for the complex transfer loads from the wood structure above. We also run a full structural analysis on the concrete base by automatically plugging into ETABS. You can download the programmatically built ETABS model to review the reinforcement details in the same environment that you trust. At the end of the pipeline, we compile all structural analysis results into one Genia calculation report, an open book audit trial of every engineering decision. This document covers a full design methodologies and parameters following IBC and ASCE 7. We provide granular load distributions showing exactly how wind and seismic forces are distributed across each floor. Many of you are already familiar with Genia's wooden design output. Here you will see force calculations not only for each floor, but also each beam, column, shear wall, post, and truss. We provide the moment, shear, and deflection under the controlling load combination, as well as the demand capacity ratio with our material selections in the detail member report. What's new today is the concrete portion. For the first time, we're compiling results for our wood engine directly with the ETAP simulations for the concrete podium. In these pages, you'll see the displacement results, shear force diagrams, and moment contours generated via our ETAP integration. We're effectively merging 2 analysis roles into one seamless, permit-ready document. Finally, the result isn't just a PDF. It's a living model. Genia exports the finalized design back into Revit as a full structural model. Look at the level of details. Every wall stud, every floor truss, every joist, and every concrete column is modeled with precision. We've bridged the gap from architectural intent to a buildable reality. This is 5/2 engineering at the speed of thought. We're currently looking for pilot opportunities for this specific kind of project. If you have a project in the work and want to see how Genia can accelerate your workflow, please reach out to me directly. Let's build the future of housing faster.